All right, welcome to a deep dive into something that can be pretty intimidating for a lot of Java learners, JDBC. It stands for Java Database Connectivity, and basically it's all about how our Java apps can talk to databases. You sent us some learning materials that were like a mini course on JDBC, so we're going to try to hit the most important points for someone starting out with this whole connecting to databases thing.
Yeah, the databases can definitely seem like a whole other world when you're first starting out, but trust me, once you get the hang of the basics, it's actually pretty logical.
Okay, good. So you're saying there's hope for us mere mortals.
Yeah.
So, like, imagine I've built this simple Java app, maybe something to track, I don't know, all the books I want to read, which, let's be real, is a very long list. How would I use JDBC to actually store all those book titles and authors in a database so it's not just floating around in my app's memory?
Okay, so think of JDBC as like a language interpreter. Your Java code, right? It speaks Java.
Yeah.
And your database, whether it's MySQL, PostgreSQL, whatever you're using, speaks SQL. JDBC is that bridge between the two, letting them understand each other and have a nice little chat.
Okay, I like that. I'm picturing this little JDBC interpreter, like frantically translating back and forth between my Java app and the database. So what kind of conversations, so to speak, are they actually having?
Well, first, your Java app would probably want to connect to the database, right? And for that, it needs the database's address. We call that the database URL. It also needs a username and password. Think of it like showing your ID to get into, I don't know, a really cool library full of data.
The database club, very exclusive.
Exactly. And then once you're in, you can start sending queries. Think of them like instructions or questions to the database. Like you could ask it to find all the books by a certain author, add a new book to your list, mark one as read hopefully lots of those, or even maybe delete one if you decide you're never going to get to it.
Ouch, deleting books from my to-read list, that hurts. But okay, I see how that works. And JDBC is handling all that back and forth seamlessly. Like I don't need to manually translate each instruction.
Exactly. And all the tools you need to do all this live in a special package in Java. It's called java.sql. It's like your JDBC toolbox. It has all the pre-built code you need for these conversations with the database.
So I'm guessing before I can even start talking to the database, I need to tell Java which specific database I'm using, right? Because I imagine they all have their own little quirks and ways of doing things.
That's a really good point. In the old days, you had to manually load something called a JDBC driver, which was specific to the database you were using. But modern Java versions are smarter, thankfully. If you have the driver library, think of that as a set of instructions for talking to that particular database. If that's in your project's class path, Java figures it out automatically.
Okay, that's a relief. I'm all for less manual configuration. So once Java knows which database we're dealing with, how do I actually open that connection? Is it like knocking on the database's door and saying, hey, let me in?
It's a bit more formal than that, but the idea is similar. You use this method called drivermanager.getConnection, and you pass it those important pieces of information. The database URL, which is like the database's address, plus your username and password. That's how Java knows you're allowed to be there.
So it's like a digital handshake with the database, making sure I'm authorized to be there.
Got it.
Okay, so I'm in. I've shown my ID. I'm ready to go. Is that when I start firing off my SQL queries?
You're on the right track. But before you start sending off those queries, you need to use something called a statement or a prepared statement object. They're both tools in JDBC for, well, executing your SQL queries.
Wait, hold on. Two different things for the same job. Now you're losing me a bit. Is one of them like the better way to do it?
So a statement is pretty straightforward, like a simple messenger. You give it a plain SQL query, like a raw string, and it just sends it off to the database. It works fine for simple one-time queries, but there are some risks involved, especially if you're not careful about security.
Okay, I'm sensing a but here. Risks. Like what? My app getting hacked.
Potentially, yeah. Using statement can leave you open to something called SQL injection attacks. Imagine someone like a hacker sneaking malicious code into your database by disguising it as part of your query. It's like handing someone a note to deliver without checking what it actually says.
Oh, that does sound a bit sketchy. So what's the safer way to do it? You mentioned something else.
Right, that's where prepared statement comes in. Think of it like a super secure messenger. It doesn't just blindly send your query off. Instead, it precompiles it, which helps with performance too. But the important part is it uses placeholders for any values you're putting into your query.
Placeholders, so like filling in the blanks. Can you give me an example?
Sure, so let's say you want to find a book in your database with a specific ID number. With a plain statement, your query might look like this. Select from books where bookid equals 123, but what if that 123 was actually like malicious code disguised as data.
Uh-oh, I'm getting nervous. So how does a prepared statement prevent that?
With a prepared statement, it would look more like this. Select from books where book Kitakule. You see the question mark there. That's the placeholder. You provide the actual value, 123, in this case, separately. That way, the database knows it's just data and not some sneaky code trying to cause trouble.
So the prepared statement is like vetting everything before sending it along. Makes sense. But is there any downside to using this? Like, is it slower or something?
Actually, it's often faster because the database can do some prep work ahead of time. Plus, you get that added security benefit, which is huge. So it's pretty much a win-win.
Okay, I'm sold on prepared statement. So I've sent off my super secure query. What happens next? How do we get the results back from the database?
That's where something called the result set comes in. It's like the package the database sends back to you, containing all the data you requested, all the book titles and authors in your case.
I like it. So I send off my question, and I get a nice little package in return. But I can't just tear it open, right? There's got to be a proper way to handle this result set.
You got it. You use a method called next to move through the results, kind of like flipping through pages in a book. And then there are all these get XXX methods, get string, get int, so on, that you use to actually grab the data you want from each row.
So if I wanted to get the title of a book, which is stored as text, I would use getString.
That's it. And you'd tell it which column of the result you want to get that data from. It's all very organized and methodical.
This is making a lot more sense now. So we've covered how to connect, send queries the right way, and then grab the results. Anything else crucial I need to know before I go wild, connecting my app to all sorts of databases?
There's one more really important step, and honestly, it's where a lot of beginners trip up. Remember we talked about opening a connection to the database? Well, you absolutely have to close that connection when you're finished. It's like closing the door behind you when you leave the library.
Oh, right. I remember seeing that somewhere. But how important can it really be? What's the worst that could happen if I just forget?
So forgetting to close your connections can lead to some pretty nasty consequences, especially if your application starts getting used by a lot of people. The database only has so many connections it can handle at once. If you leave them open, it's like hoarding all the books and no one else can get to them.
I would want to be that person hogging all the books.
Right. It can really slow things down, cause all sorts of performance problems, and in some cases, even crash the whole database server.
Yikes. Okay, I'll definitely try to remember to close those connections. So to recap, we've got load the driver, open the connections, send statements, get the results, and close the connection. Did I miss anything?
You got it. Those are like the 5 commandments of JDBC.
Right? 5 commandments. I can handle that. This is all starting to feel a lot less intimidating now. All right, so we've covered a lot of ground already. We talked about how JDBC acts as this bridge between our Java code and the database, letting them have a conversation. And we went over those 5 key steps. Load the driver, open the connection, send our queries preferably with prepared statements to keep things secure, get our results back in a result set, and very importantly, remember to close that connection when we're done.
I think you've summarized it perfectly. Those 5 steps are like the foundation of working with databases from your Java applications. And yeah, prepared statements definitely the way to go for both security and performance.
Right. It's like having a security guard and a speed booster all rolled into one. Okay, so now that we have the basics down, I want to circle back to something you mentioned earlier, transactions. You said they're like hitting undo for a bunch of database actions. I'm intrigued, but my brain needs a bit more explanation.
Of course. So transactions are all about like keeping your data consistent and reliable, even if things go wrong. Think back to that online banking app we were talking about earlier. Imagine you're not just transferring money between accounts, but you're also updating transaction logs, maybe even calculating interest and fees, all of that happening as part of one process.
Okay, yeah, and if something interrupts that process, it could really mess things up, right? Money disappearing, records not matching up, basically a developer's worst nightmare.
Exactly. That's where transactions come in. By wrapping all those operations within a transaction, you're basically saying to the database, hey, treat all of these actions as a single unit. If any one of them fails, just revert everything back like nothing ever happened.
So it's like a safety net for those multi-step database operations. But how do I actually tell the database to treat a bunch of actions as a transaction? Is there a special JDBC command for that?
There is. It all starts with the connection object, the same one we use to establish the connection with the database in the first place. By default, the connection works in what we call auto-commit mode. So each individual SQL statement you execute is automatically committed to the database as soon as it's done.
So it's like each statement is its own little mini transaction getting saved right away. But for those bigger multi-step processes,
Yeah.
we need more control, right?
You got it. To use a transaction, you first need to turn off that auto commit mode. You do that by calling connection.setAutoCommit false. That basically tells the database, hey, hold your horses, don't commit anything yet, wait for my instructions.
Okay, so I've flipped the switch to manual mode. Now the database is patiently waiting for me to tell it what to do. So what happens next?
Now you can go ahead and execute all those SQL statements that are part of your transaction, like deduct money from one account, add it to another, update those transaction logs, whatever needs to happen. But here's the key. None of those changes are actually written to the database permanently yet. They're just like queued up, waiting for your final command.
It's like I'm setting up a series of dominoes, making sure everything is lined up perfectly before I give that first one a push. So how do we give that final command, the one that either makes all the changes permanent or reverts everything back?
JDBC gives you two very simple methods for this. If everything went smoothly and you want to make those changes stick, you just call connection.commit. It's like saying, okay, database, go ahead and make it official.
So that commit command applies all those queued up actions as a single unit. No going back after that.
Right, it's all or nothing. And if something went wrong along the way, maybe one of your SQL statements had an error or there was a network issue or something, you simply call connection.rollback. That tells the database to just discard all those pending changes. It's like hitting the undo button for the entire transaction.
Okay, so it's like having a commit button and a rollback button for my entire sequence of actions. I like it. But what if I forget to call either commit or rollback? Does the transaction just kind of hang there in limbo forever?
That's a really good question. Ideally, you always want to be very explicit about committing or rolling back your transactions just to keep things tidy. But what happens if you forget can actually depend on how your specific database and JDBC connection are configured. Sometimes there are timeouts that kick in, or the connection might get closed automatically, which could trigger a rollback.
So the safest bet is to be diligent and always clean up after myself, just like I learned to do with those connections. No stray transactions floating around causing mischief.
Exactly. Good transaction management is essential for keeping your database happy and healthy.
All right, I'm getting the hang of this. Transactions are basically a way to ensure that even if something unexpected happens, my data stays consistent and reliable. But before we move on, I want to be crystal clear about something. When I turn off that auto commit mode, does that mean absolutely nothing gets committed to the database until I explicitly call commit? Like, even if I'm just reading data and not making any changes?
That's an excellent question, and it's important to understand this nuance. Yes, when you set auto commit false, you're essentially pausing the automatic saving feature. All your SQL statements, even simple select statements that are just reading data, become part of that pending transaction. Nothing becomes permanent until you hit that commit button.
So even if I'm just browsing the database, so to speak, I still need to manage that transaction properly?
Technically, yes. But for read-only operations, it's often more efficient to just leave auto commit turned on. The real benefit of transactions comes when you're mixing reads and writes within the same block of code. That's when you want to make sure everything is treated as a single atomic unit.
This is giving me a much deeper appreciation for the level of control JDBC gives me over how I interact with the database. It's not just about sending off queries, it's about managing the entire conversation in a way that keeps things safe, consistent, and reliable.
You got it. JDBC isn't just a simple messenger. It's a powerful tool for orchestrating complex database interactions.
I'm definitely feeling more empowered. But you know me, I always worry about performance. All these fancy features, transactions, prepared statements. Do they slow things down?
That's a very valid concern. Performance is always something to keep in mind, especially when you're dealing with databases. And yes, features like transactions and prepared statements do add a tiny bit of overhead compared to just blasting off raw SQL queries.
Okay, so there's a trade-off. We gain security and consistency, but maybe at the cost of some speed. How do I strike the right balance?
It's all about choosing the right tool for the job and understanding the nuances. For instance, with prepared statements, while there is that initial overhead for preparing the statement, they often end up being faster overall, especially if you're executing the same query multiple times with different values. It's like taking a little extra time to sharpen your axe before chopping wood. It might seem slower at first, but you'll get the job done much faster in the long run.
So that pre-compilation step actually saves us time in the end. What about transactions? Any tips for minimizing their performance impact?
Definitely. The key principle is to keep your transactions as short as possible. Only include the operations that absolutely need to be treated as a single unit. The longer a transaction runs, the more resources it ties up, potentially slowing down other things that are trying to use the database.
So it's like being efficient with my time at the grocery store. Get in, get what I need, and get out to avoid holding up the line.
Exactly. And there are other optimization techniques you can explore, like optimizing your SQL queries, using indexes, and even diving into different transaction isolation levels, which control how transactions interact with each other.
Okay, those sound like more advanced topics for another day.
Mm.
For now, I'm feeling pretty good about the core concepts of JDBC and how to use it safely and effectively. But you know how my brain works. I'm already thinking about the next level of complexity. All this code we're writing to handle database interactions, it can get pretty messy, right? Especially as our applications grow.
You're absolutely right. It's tempting to just cram all your SQL queries directly into your Java code, but trust me, that will come back to bite you later on. It becomes a nightmare to maintain and debug.
I can imagine. It's like trying to find a needle in a haystack, except the haystack is made of code, and the needle is that one tiny SQL query that's causing all the trouble.
That's a perfect analogy. So here's a pro tip. Create a separate class specifically for storing all your SQL queries as constants. This makes your code so much cleaner, more organized, and easier to understand.
So instead of having SQL queries scattered all over my code, I centralize them in a dedicated class. That way, if I need to change something, I know exactly where to look.
Exactly. It's like having a well-labeled spice rack where you can instantly find the ingredient you need. And actually, the material you sent had a good example of this, a class called SQL Queries that did just that.
I like it. Organization is key. Any other best practices you'd recommend for someone starting out with JDBC?
Here's a big one that often gets overlooked until it causes problems. Error handling. Things don't always go as planned in the world of databases. You might run into network errors, invalid data, even database crashes. You have to be prepared for those unexpected events.
Okay, so things can go wrong. How do I make sure my application doesn't just completely fall apart if the database throws a tantrum?
That's where something called exception handling comes in. JDBC will actually throw exceptions. Those are like error signals when something goes wrong. You need to write code to catch those exceptions and handle them gracefully.
Gracefully?
Meaning, don't let the whole application crash. You might log the error, display a user-friendly message, or even try to recover from the error if possible. It's about making your application resilient and able to handle unexpected situations.
So it's like having a backup plan, just in case things go south. Instead of panicking, my app can handle the situation calmly and professionally.
Exactly. Good error handling is crucial for building reliable and user-friendly applications.
Okay, I'm taking notes. Robust error handling, centralized SQL queries, these are great tips. Anything else?
One more thing, and this one's important for performance, especially as your application scales. Connection pooling. Remember we talked about how opening and closing database connections can be a bit expensive, like leaving the door open and letting all the heat out?
Right, we want to minimize those open-close cycles.
Exactly. Connection pooling is a technique where you basically create a pool of pre-initialized connections that can be reused by different parts of your application. It saves a lot of overhead from constantly creating and destroying connections.
So it's like having a fleet of taxis ready to go, instead of having to hail a new one every time I need a ride. Much more efficient.
Precisely. Connection pooling can make a big difference in how smoothly your application runs, especially if you have a lot of users or requests happening at the same time.
This is all starting to click. But I have a confession. My head is starting to spin a little bit with all these concepts and techniques. Is it normal to feel a bit overwhelmed at first?
Absolutely. JDBC and working with databases in general can be a lot to take in, especially when you're just getting started. But don't worry, it becomes much clearer with practice and experience. Start with the basics, experiment with some simple examples, and gradually build up your knowledge and skills.
That's reassuring to hear. It's like learning any new skill. It takes time and patience. Speaking of learning, was there anything specific in the materials you reviewed that you found particularly helpful or interesting?
You know, there was this one example that really stood out to me. It was about retrieving data from a result set and then processing it to display a list of, I think it was to-do list items. It showed not only how to fetch the data, but also how to structure your code to handle different data types and potential errors gracefully.
So it was like a practical demonstration of how to take those raw database results and turn them into something meaningful for the user.
Exactly. It's one thing to understand the mechanics of JDBC, but it's another to see how it all comes together in a real-world application.
I'm all about those practical examples, like having a recipe to follow instead of just a list of ingredients. But before we get too caught up in specific code examples, maybe it's time for another quick recap. We've covered so much in this deep dive already: transactions, best practices, even performance considerations. Is there anything else you think is crucial for our listener to know at this stage?
Let me see. We've talked a lot about how to interact with the database using JDBC, but maybe we should take a step back and talk about how to choose the right database in the first place.
That's a great point. We've been assuming our listener already has a database all set up and ready to go, but choosing the right database for your project is a pretty big decision. And I'm guessing there's no one-size-fits-all answer here, right?
Definitely not. There are so many different types of databases out there, each with its own strengths and weaknesses. The right choice depends on a lot of factors, like the size and complexity of your project, your budget, the performance you need, even the expertise of your team.
So it's like choosing the right tool for the job. You wouldn't use a hammer to screw in a light bulb.
Exactly. And just like with tools, there are different categories of databases. You have relational databases like MySQL and PostgreSQL. Those are great for structured data, the kind that fits neatly into tables with rows and columns. And then you have NoSQL databases like MongoDB and Cassandra. They're better for unstructured data or data that doesn't fit that traditional table format.
Okay, so relational databases for organized data and NoSQL for more flexible, less structured data. How do I know which one is right for me?
It really comes down to understanding your data and how you'll be using it. If you're building something like a to-do list app, where you have clear entities like tasks, users, categories, a relational database is probably a good fit. But if you're dealing with something like social media data with lots of text, images, and relationships that change all the time, a NoSQL database might be a better choice.
I'm starting to see the bigger picture here. Choosing the right database is like laying the foundation for a house. You need to make sure it's the right type of foundation for the kind of structure you're building. But once I've made that decision, is actually setting up a database something I can do myself, or do I need to call in the professionals?
Well, you can definitely do yourself. Most databases are surprisingly easy to set up. You can install them locally on your own computer, or you can use a cloud-based database service.
Cloud-based databases. Those sound intriguing, but also a bit mysterious. Tell me more.
Think of it as outsourcing the management of your database to a third-party provider. They take care of all the hardware, the software, the security, the backups, all of that. You can just focus on building your application.
So it's like having a professional database administrator at my fingertips without having to actually hire one myself. That sounds pretty appealing, especially for someone who's just starting out.
It can be a great option, especially for smaller projects or during the development phase. And cloud databases often have flexible pricing, so you only pay for what you use.
This is opening up a whole new world of possibilities. Okay, so I've chosen my database. I've got it set up either locally or in the cloud. I'm feeling pretty confident about my JDBC skills. What's the next step? How do I actually start designing the structure of my database, like those tables and columns you mentioned?
That's where we get into the art and science of database design. You need to think about the different types of data you want to store and how they relate to each other. For example, in your to-do list app, you might have a table called tasks. And that table would have columns for things like the task description, the due date, the priority, maybe a status column to track whether it's complete or not.
Okay, I see. So I'm essentially creating a blueprint for how my data will be organized within the database.
Exactly. And you might have another table called users to store information about the people using the app. And then you can define relationships between those tables. For instance, each task might be associated with a specific user, so there would be a link between the tasks table and the users table.
This is starting to feel like I'm building a virtual world with its own structure and rules. Are there any tools or techniques that can help with this database design process? It sounds a bit daunting.
Definitely. One popular tool is called an entity relationship diagram, or ERD for short. It's basically a visual representation of your database structure. You can see all the tables, the columns, and the relationships between them all laid out visually.
So it's like a blueprint for my database. I can map everything out visually before I start writing any actual code.
Exactly. ERDs are a great way to communicate your database design to others, and also to make sure you've thought through all the details. And there are lots of software tools that can help you create ERDs and even generate the SQL code to actually create those tables and relationships in your database.
This is making me realize that there's a whole lot more to databases than just sending queries. It's a whole discipline with its own principles and best practices.
It is. And like any craft, there's always more to learn and ways to get better. But the most important thing is to just start experimenting, build some simple projects, and gradually expand your knowledge.
That's encouraging. I'm feeling much more confident about tackling this now. But before we wrap up this deep dive, I want to touch on one more thing. We've been talking a lot about the technical side of things, but working with databases often involves collaborating with other developers, database administrators, even end users. Any tips for navigating those interactions smoothly?
That's a great point. Technical skills are important, but communication and collaboration skills are just as crucial. Here are a few things that I found helpful.
Okay, I'm all ears.
First, be clear and concise in your communication. When you're talking about database issues or requirements, use precise language and try to avoid jargon that others might not understand.
So no speaking sequel to my non-technical colleagues.
Probably not the best approach. Second, be proactive about seeking feedback and collaborating with others. Database design and development is often an iterative process. Get input from different stakeholders along the way.
So don't be afraid to ask questions and get clarification when I need it.
Exactly. And lastly, be respectful of everyone's time and expertise. Database administrators, they're often the unsung heroes, keeping those databases running smoothly behind the scenes. Treat them with the respect they deserve, and they'll be much more likely to help you out.
Those are some great tips. It's a good reminder that technology is rarely built in isolation. It's a team effort, and communication is key.
Absolutely. And that's true in pretty much any field, not just software development.
Well, I think we've covered a ton of ground today. We started with the nitty-gritty of JDBC, and we ended up talking about choosing databases, designing database structures, and even the importance of good communication. I feel like I've gone from JDBC newbie to, well, maybe not an expert yet, but definitely more comfortable and confident. What about you? Anything else we should cover, or are we ready to wrap things up?
I think we hit all the major points, but there is one thing that just popped into my head. We've talked a lot about how to write JDBC code, but we haven't really discussed how to test that code.
Testing. Crucial for any software development, but I have a feeling testing database interactions is a bit trickier than just testing regular code. Can't I just run my code and see if it works?
It can be a bit more involved than that. With databases, you have to think about the state of the data, potential concurrency issues, and the performance of your queries. You don't want your tests accidentally messing up your real data or bringing your application to a grinding halt.
Okay, so testing with databases requires a bit more care. What are some good practices for approaching this?
One common approach is to use a separate test database, one that's completely isolated from your production environment. That way you can run your tests without worrying about corrupting any real data.
So it's like having a safe space to experiment in where I can break things without any real consequences.
Exactly. And within your tests, you want to set up specific data scenarios, run your JDBC code, and then verify that the database ends up in the expected state.
So it's not just about checking if my code runs without errors, but also making sure it's actually doing what it's supposed to be doing with the database.
Precisely. And there are lots of tools and frameworks that can help with this, like JUnit for writing unit tests and DBUnit for managing your test data.
This is giving me a much better idea of how to approach testing when it comes to JDBC. It's definitely not something to be overlooked. But before we get too deep into testing, maybe it's time to start wrapping up this deep dive. We've gone from the fundamentals of JDBC all the way to testing strategies. That's a lot to process.
You're totally right. Testing is super important. And actually, now that you mention it, I do remember something in the materials about mocking. Was there anything specific about testing JDBC that stood out to you?
There was a section about mocking database interactions for testing. It's really helpful when you want to isolate your code from the complexities of using a real database while you're testing.
Mocking, so like creating a fake version of my database.
Yeah. Mocking is when you make these dummy objects that act like the real database components. The connections, statement, and results that we talked about. That way, you have total control over what data your code gets during testing. So instead of my code actually talking to the database and running queries, it's talking to these mock objects that give it pre-programmed responses.
Exactly. It's like giving your code the answers to the test beforehand.
Sneaky. So when would I want to do that?
It's really helpful when you're testing complex logic that depends on specific data, or if you just want to avoid the hassle of setting up a whole separate test database.
So it saves time and lets me focus on testing just the logic of my code without worrying about the database itself. Smart. But I guess you wouldn't want to mock everything all the time, right?
Right. Mocking should be used strategically to isolate parts of your code. You'll still want to do integration tests that use a real database to make sure everything works together properly.
Makes sense. Balance is key.
Hmm.
Well, I think we've covered a ton of ground in this deep dive. We went from the very basics of what JDBC is to some pretty advanced concepts like transactions, best practices for writing clean code, and even testing strategies.
We even talked about choosing the right database for your project and got into connection pooling and all sorts of other good stuff.
I'm feeling way more confident about using JDBC in my own projects now. Is there anything else you think we should mention, or are we good to wrap things up?
I think we've hit all the key points, but I do have one last bit of wisdom to share.
All right, lay it on me.
Remember that learning to code is a journey, not a destination. JDBC and databases are huge topics, and there's always more to learn. Don't be afraid to make mistakes and just experiment. And most importantly, have fun.
Couldn't have said it better myself. It's like exploring a new world. You don't have to see everything at once. You can take your time and enjoy the process of discovering new things.
Well, on that note, I think it's time to say farewell to our deep diver out there. We hope you've enjoyed this journey into the world of JDBC and that you're feeling inspired to keep learning and exploring. Until next time, happy coding.